Hello everyone, my name is Saili Kadam. In this video, we will be talking about regression algorithms and specifically linear regression. So previously, whatever we discussed were again supervised learning algorithms, but they were focused on morely or they were mostly used for classification. We know what is the difference in between classification and regression. We saw some of the algorithms which we used both for classification as well as regression. So in this video or coming videos, in our upcoming videos, we will be talking about algorithms that are specifically made for regression. And in this video, we will be focusing on linear regression. So let us get started. So basically, what is a linear regression? Linear regression is again a supervised learning algorithm. So a supervised learning algorithms, that means we will have inputs and outputs. We know what is a supervised learning algorithm by now. Then we used to predict. Obviously it is a regression algorithm, so we won't classify anything. The output of the this method or this algorithm will be a numerical value and the working principle. So basically we are predicting something. We Linear regression, we use it for predicting, or like let us say house price prediction or marks prediction. So basically the output that we are going to get, it won't be whether it is the mail is spam or not or something like that. It will be completely a numerical value, what will be the temperature tomorrow or something. So basically it is a regression algorithm. The output of it will be a numerical value, and it is basically how it works, the very important concept behind linear regression. So every algorithm has some main concept behind it, as knn has the value of k, then naive bayes is Bayes theorem, we use their Bayes theorem. Then SVM, there we study the concept of margin. So there are this concept every algorithm has, which is unique for that specific algorithm only. So here in this algorithm, the main concept behind this algorithm is finding the best fitting straight line. So this is how. So we can say that it is quite similar to margin of SVM, but in SVM the aim is to maximize the difference in between the data points and the hyperplane. That is what we do in SVM, but here the aim is to find a best fitting line. So basically best fitting line is that a line or something passing a point that passes closely to the data points. That is basically, we are going to learn about them shortly, but this is how linear regression works, and the goal is to minimize the difference between the actual values and the predicted values. So we will have some values, already given data points, and we are going to predict something. So our aim will be whatever the actual values are, they should be their difference should be minimum. It should not be maximum. In SVM is focused for classification. That is why we want a margin in such a way that clearly differentiates different classes. So that was our aim in SVM. But here we want a answer, or we want a value to be close to their actual values, and that is basically the best fitting line. So basically best fitting line is the line from where the difference in between the actual values and the predicted values is minimum. So we are going to take an example and understand how exactly linear regression works. So this is how. So linear regression, there are few points that we need to remember for linear regression. First one is it is a supervised learning algorithm. Then the working principle is we try to find out the best fitting straight line. And what do we mean by best fitting straight line? That is the difference in between the actual values which are actually present in the data set and the values that are predicted by us, that should be minimum. So this is the aim or main goal of linear regression. So let us take an example and understand the working of linear regression. So this is the sample data point, that is data set given to us, that when a student studies for 2 hours, he or she obtains 45 marks. If the student studies for 4 hours, the marks obtained is 55. So this is something we are going to study the assumptions of this algorithm. But just to start with, this is the data set that we are given with, and we need to find out. So we are given at different intervals, like the difference in between the interval is of 2. So whenever a student, as soon as the number of hours studied increases, the marks obtained also gets gradually increased. So the question is to find out how, like if a student studies for 5 hours, how much will that student score? This is what our aim is to. This is a numerical value, it will be a numerical value. So that is why it is a regression problem. So now what will we do? We will plot this graph. So when we study for 2 hours, we obtain 45 marks. So the x-axis is for the hours studied and y-axis is for the marks. Then if we study for 4 hours, we score 55 marks. So this is how we plot the entire data set that is available for us. And here comes the concept of the best fit line. So best fit line is the straight line that passes as close as possible to the data points in the data set. So on the previous slide we discussed the same thing, that the main aims to minimize the difference in between the actual points. So these are the actual points of the data set, and there will be something that we will predict. So the aim is to find a straight line in such a way that it passes close, as close as possible. We don't want as far as possible, we want very close, a line such that the nearest data points are very close to that line. That is the best fit line in linear regression. So now we need to predict at 5 hours. So when a student studies for 5 hours, how much that student will score. So 5 will be coming in between 4 and 6. So 5 will be somewhere here. Then when a student studies for 4 hours, he or she scores 55 marks. And when he or she studies for 6 hours, he or she scores 70 marks. So our new predicted value will be somewhere in between 6 and 4. So it will be somewhere here in between 4 and 5. So we can say that our predicted value will be somewhere here. And then the aim that we have is to minimize the distance. So we will select a point in such a way that the distance in between these 2 points and this new value is minimum. So this is 55 and this is 70. So that means the difference is of 15. So something like it will be something around 62 or 63 marks something. So that will be the minimum distance in between both of them, and it will be somewhere around 62 or 63. So we can say that when a student studies for 5 hours, he or she may score around 63 or 62 marks, let us say 63 marks. So this is how linear regression works. The linear regression, the main concept behind linear regression is to find out the best fit line. What do we mean by best fit line? A straight line in such a way that the difference in between the actual data points and the predicted points is minimum. This is what we mean when we say best fit line. So I hope you understood how linear regression works. Then we have different ways in which we find out the best fit line. So basically there are 3 different ways in which we can find this line. In detail we will be talking about these 3 methods in our upcoming videos. So the first point is ordinary least square method, then numerical solution and gradient descent. It is a very important concept and it is used in different algorithms as well. So we studied one thing, XGBoost. So that is also XGBoost and gradient boosting. Again there we use gradient descent. So we will have a dedicated video for gradient descent. So these are 3 ways in which we can find out the best fit line. Then we have assumptions. As every algorithm has some assumptions, even linear regression has its very concrete assumptions, and the very important assumption of linear regression is linearity. Very important. So linearity is it assumes, linear regression assumes that the relation in between x and y, x is, we say that, dependent and independent variable. In our previous data set we had x as the number of hours a student studies and y was the marks obtained. So linear regression assumes that both of them are linear. That means as soon as independent variable increases, even dependent variable will be increasing, so the growth will be linear in between both of them. And independence, again, this is a very important assumption of linear regression, that is, the observations are independent of each other. This is a very important assumption of linear regression. Then it also says that the variance of the errors is always constant no matter what are the observations. The error of the variance will always remain constant. Then the errors follow normal distribution. What do we mean by normal distribution? Normal distribution looks something like this. So these are normally distributed. The errors are normally distributed. This is what we mean. This is what linear regression assumes. And then features are not highly correlated to each other. So this is exactly independence. We can say that they are independent. They are not very related to each other. These are the assumptions of linear regression. Then again, this algorithm has advantages, that it is simple and fast. It works well when we really, so in our real world data sets, this may or may not happen that the features they are exactly linear to each other. They may also not be linear, but when we have exact linearity, or when the data set is truly linear, as soon as the one feature or the value of one feature increases, the value of other feature also increases. If that is present in this data set, then linear regression works best there. Then again, it has some of the disadvantages. So the disadvantage is it cannot capture non-linear relationships. So the thing is that it assumes that everything is linear, so it may or may not capture the non-linear relationships. Then it is very sensitive to outliers. So let us say there is only one data point that is somewhere. So like let us draw a similar graph. So like first point is here, the second one is here, and the third one is very, like, so if a student studies for 2 hours, this is what he scores. If the student studies for 4 hours, this is what he or she scores. So we again need to predict at 5. So 6, it is, the difference is too big. It is not like, this is the outlier. We can say that it is outlier. It may happen that when a student studies for 8 hours, he or she scores decent, like this is how it looks. So all these things are good to go. I mean, they are linearly increasing, but there is only one point that deviates a lot, or this, we call this as outlier. This point we call it as outlier. But when we will say that, when we need to predict what will be the marks when we calculate for 5 hours, so this is what we are calculating. So obviously it will come somewhere here, which may or may not be correct. So the output of linear regression gets affected by outliers, and it assumes all the features. So basically, it, whenever it is predicting something, it will consider all the features, feature importance and everything. It don't consider all those things. So this were advantages, disadvantages, assumptions and working of linear regression. Then applications of linear regression are morely, or mostly we use linear regression in prediction systems, where we predict other things. Like we can use this in house price prediction, we can use this in marks prediction, temperature prediction. So whenever we have prediction systems, there we use linear regression. So I hope we understood how exactly linear regression works. In our upcoming videos, we will be talking about gradient descent, most importantly, because it's been two topics that we have covered which are based upon the gradient descent. So I think the next topic should be gradient descent. and then we can continue with logistic regression and further concepts. So that's all for this video. Thank you.